Good afternoon, ladies and gentlemen. My name is Widyarani from Research Unit for Clean Technology in Indonesian Institute of Sciences. This afternoon, I will present the result of our framework, the impact of COVID-19 prevention measures on water quality, an Indonesian perspective. So this is the background of our study. As we already know that COVID-19 has become a global pandemic with, as of yesterday, 68 million cases worldwide. In Indonesia itself, more than 500,000 cases already detected. We know that there are 3 prevention measures recommended by WHO, physical distancing, wearing masks, and hand washing. We already know that this measure can prevent the virus spread, flatten the curve, but what we would like to know in this study is the impact on water quality. So the first measure is physical distancing, which is often applied as lockdown or restriction of activities such as travel and industrial activity. And we see a lot of this kind of pictures earlier this year when people say that the earth is healing and the nature is bouncing back, etc., which is a very impressive figures. But actually, we also have some hard data about the impact of this physical distancing. We have overwhelming data from India, from Ganga River, Yamuna River, Dwarka River, Sabarmati River, Pembenet Lake, Tuticorin District, and coastal area. It was observed that several pollutants show a downward trend. It was also observed that higher water transparency and lower suspended matter occurred in Venice Lagoon, Italy. In coastal Morocco, it was observed that the water surface temperature was lower. And in Indonesia itself, it was observed that chlorophyll A concentration, which is a measure of eutrophication, is also decreased. On the other hand, since people are forced to stay inside, there are another side effect. This is data from Gojek, which is a service provider in Indonesia. Their data show that food transaction was tripled during the pandemic. Also, online shopping transaction also tripled, and courier service almost doubled, which is in itself is not a bad thing. But these activities use a lot of packages, and these packages sometimes end up in municipal solid waste. So our tomorrow's keynote speaker probably discuss more about this, but what we know that sometimes these municipal solid waste also end up contributing to water pollution, which is also the impact of the second measure, wearing masks. Because we also receive a lot of report about the mass littering public spaces, and even if it's dumped in landfill, it can still release some fragment and end up in the river or the oceans. The third prevention measure is hand washing. As the previous presenter actually already discussed at length, the hand washing actually has the most direct impact on water quality. So because it produces wastewater, which can increase by volume. It also contains some micropollutants. The most notable is biocides on surfactant, but it also contains a fragrance, UV filters, pesticides, preservatives, etc. We also need to rethink our treatment technology. What is the current capacity of treatment? What is the technology available, and what is the policy that is implemented? So to summarize the impact of each individual measures, the physical distancing measure can lower the pollutant load. Lower the pollutant load due to lower activity, mainly from industries. But it also can potentially increase water pollution from the increased municipal solid waste. The wearing mask impact can potentially increase water pollution from PPE or medical waste. The hand washing may impact in increased water use, increased wastewater generation, and increased micropollutant load. And as previous presenter also showed, that it also increased the concentration. But the question is, what is the overall impact of these three measures? We currently do not have data yet, but we can try make a simplified model. We use Citarum River in West Java, Indonesia, as a model system. We know that in the upstream, the river is still very pristine, very clean, but along the way, there are some activities, industrial, domestic, and agriculture, which generates water pollution. So in the downstream, the quality deteriorate. So we try to calculate the impact on organic concentration, or COD. In the left side is the business as usual scenario. So at the upstream, we see that the concentration of the pollutant is still very low, but there are a lot of pollutants from industry and domestic. So it results in more than 10 times COD concentration in the downstream. We tried to simulate the COVID-19 scenario, so to say, in which the industrial activity decreased by 5% and domestic activity increased by 5%. And you can see here that the COD concentration in the downstream in COVID scenario is 1% higher than the business as usual scenario, which implies that the domestic wastewater has higher impact compared to industrial wastewater. The impact is actually much more pronounced in phosphate. We can see here that comparing business as usual scenario with COVID scenario, in COVID scenario, the concentration downstream is 2.7% higher compared with business as usual. And we know that phosphate is a component of detergent, which means that phosphate can be an indicator of the other micropollutants that is present in domestic wastewater.
1 more minute.
This is the last. Okay. So for closing remark, these prevention measures, particularly hand washing, will add additional pressure on clean water system. Therefore, we need to maybe rethink our domestic wastewater treatment in terms of policies, initiatives, also how it can be implemented. and we also need to rethink a new technology or approach for particularly for persistent micropollutants. So that's my final remarks. Let's stay safe and healthy. Thank you for your attention.